Hi, welcome back to Moose and Chemistry. This is electron configuration of ruthenium, RU lesson. Now, I'm going to let you know that ruthenium, ruthenium, palladium, and silver is what I call Nightmare Alley because they are 4 exceptions in a row. So here's the first one, ruthenium. Now, ruthenium has an atomic number of 44 because it is element number 44. So let's go ahead and write 44. And its atomic mass number is 101. Okay. So we're going to have 44 protons, 44 electrons. What about our neutrons? Well, it's simple. AMU minus protons equals the number of neutrons, right? So we're going to go 101 minus 44 gives me 57 neutrons. So I'll write 57 here. Pretty cool, huh? Sure is. It's about the easiest thing that's going to be for these next 4 elements. All right, now let's think about this. Our electron configuration. Now remember that the s suborbit holds 2 electrons, the p suborbit holds 6 electrons, the d suborbit holds 10 electrons, and the f suborbit holds 14 electrons. We're going to use the off-ball principle, which states that the lower shells get filled first before the upper shells. And we're going to do it by the diagonal rule. Here's our diagonal rule. Start at 1s. Okay, that's a good point. 1s2. 2s2. 2p6. 3s2. 3p6. 4s2. 3d10. Yes. And 4p6. Now, notice I delayed there. This is going to become 5s1 4d7. Yep, that's what it is. 5s1 4d7. Man, I'm going to tell you, you've got to watch out for these exceptions. Okay? So now let's look at this orbital notation. Hund's rule says that you got to put an up arrow before you put a down arrow in every suborbit. So let's go ahead and do this. Up and down. Up and down. Now here's a perfect example of Hund's rule. 2px, 2py, 2pz. Right? Every suborbit gets an up arrow. There you go. And then you do your down arrows. So go ahead and kind of work it that way for the rest of this. I'm going to put these down. See how that works? Works pretty darn good. Getting there, we're almost done. Remember, 5s only has 1. 4d has 7, right? 1, 2, 3, 4, 5, 6, and now 7. Okay, what's an exception? Just go with it, okay? Now, noble gas notation. The nearest noble gas is krypton. So we're putting Kr here. And now, it's important to write this numerically in order. 4d7, 5s1. Because I showed people how that mistake was made using tacticity, which is element number 43. Okay, let's do our quantum notation. That deals with Pauli's exclusionary principle, right? So there are no 2 elements have the same set of quantum numbers. So let's look at our n value, our principal quantum number first. Well, it looks like ruthenium is in the 5th period, but it's not, because it's a D block. Remember, D block is n minus 1. So it's going to be 5 minus 1. Right? So it's actually going to be... So the angular momentum is going to be 2 because it's in the D block. And it's going to be the 6th element over. So you're going to go minus 2, minus 1, 0, 1, 2, then repeat minus 2. And let's look at our last error. Our last error is actually right here. Some people think it's at the end, but it's not. Be careful of that mistake also. So it's going to give you 1/2 negative. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.